In this video, we're going to continue on with section 7.5, the multiple angle and product to sum formulas, and we're going to work more with these double angle formulas a little bit. Let's see here. In example 3, they want us to find sine of 2 theta, cos of 2 theta, and the tan of 2 theta, given that the cosine of single theta is 5/13, and we know theta is somewhere between 3/2 pi and 2 pi, which means we are in the fourth quadrant. So if I draw a triangle here, this will be our angle theta, and we know cosine is 5/13. That's adjacent over hypotenuse. So 5 is our adjacent side, 13 is the hypotenuse. Pythagorean theorem, or if you remember the triple, the 5, 12, 13 triple, we know this side will be 12. And because we are in the fourth quadrant, this is sort of our y value here. This is going to be a negative 12. So let's see. First thing we're going to find is the sine of 2 theta. Well, the sine of 2 theta is equal to 2 sine theta times the cos of theta. And these angles we can get off the triangle, or actually cos of theta was given to us. So 2, the sine of theta. From angle theta, sine is opposite over hypotenuse, or negative 12/13. Cosine was given in the setup, 5/13. And we can multiply that straight across, and we are going to get a negative 120 over 169. So come up here and save that. The sine of 2 theta is negative 120 1/69. Okay, cos of 2 theta. For cos of 2 theta, I could choose any of these formulas down here that I want. I think the easiest one to work with might be the one in the middle. So the cos of 2 theta is equal to 2 cos squared of theta minus 1. So 2, and then our cosine squared. Well, cosine is 5/13 minus 1. So we're going to square that. 2 times 25 1/69. Multiply by 2 times that numerator is 50 1/69 minus 1. Or let's get a common denominator, 169 1/69. And when we subtract that, we're going to get the cos of 2 theta equals negative 119 1/69. So look, that's pretty close to our sine value. The cos of 2 theta is negative 119 1/69. Alright, one more. We've got to find the tan of 2 theta. And we could use this formula right here. Tan of 2 theta is equal to 2 times the tan of theta divided by 1 minus tan squared of theta. So we could plug in, the tangent here. Tangent of angle theta would be opposite over adjacent, negative 12/5. We could plug that in for anywhere we see a tan of theta. Or we could go the easier route. Since we already found sine and cosine, tangent of 2 theta would be sine of 2 theta divided by the cos of 2 theta. So our numerator would be sine of 2 theta, or negative 120 1/69. Our denominator would be cos of 2 theta, negative 119 1/69. Fraction divided by fraction, invert and multiply. So up here I bring it and flip it. Now it's 169 over 119. On the diagonal, the 169s will cancel. And if we multiply straight across, negative times negative is positive. And we'll have our 120 up top and our 119 in the bottom. Okay, so we found all three: the sine of 2 theta, cos of 2 theta, tan of 2 theta. Let's see here. The double angle formulas are not just restricted to angles 2 theta and theta. Other double combinations, such as 2 theta and its double 4 theta, or 3 theta and its double 6 theta, are also valid, like these two examples. The sine of 4 theta, that's like 2 times 2 theta. That's a theta. So if we apply that to the formula, the 2 would come out front. We'd have 2 sine of half of it, 2 theta, times cos of 2 theta. We could do the same thing with cos of 6 theta with the squared formula, sine or cos squared minus sine squared. So that would be the cos squared of half of this, 3 theta, minus sine squared of the same half of the original angle, 3 theta. By using double angle formulas together with the sum formulas given in the preceding section, we can form other multiple angle formulas. Here in example 4, we're going to derive our own triple angle formula. So we're given the sine of 3x. We can replace that as the sine of the quantity 2x plus x. I just took the 3x and broke it into 2 component pieces. And now we have the sine of a sum. So if we think back to our patterns from the preceding section, it's going to be sine of something, cos of something, sine cos plus cos sine. And of course the angles are 2x and x. So the sine of 2x times the cos of x plus the cos of 2x times the sine of x. Now, here we have the sine of 2x. So this becomes, again, I sort of think about it as the 2 comes out front, 2 sine of just x, cos of x. And then we have another times this cos of x, so this will become a cosine squared. Plus, this cosine of 2x, we can replace this with the 1 minus 2 sine squared of x. So what I've underlined there gets replaced with 1 minus 2 sine squared of x. And then we have this additional sine of x. And when I did replace this cos of 2x with this 1 minus 2 sine squared, I should have had that in parentheses. That is a quantity. So for our next step here, we can distribute this sine of x throughout those parentheses. So here our first term is 2 sine x cos squared x. And then when we distribute the sine x, we're going to have a plus sine x minus 2 sine to the third of x. Now when I look across this here, I see lots of sines, and I see this one lonely cosine squared. So everything is some form of sine except this. So let's replace that with 1 minus sine squared of x. So we're going to have our 2 sine x. And we're going to replace that with a Pythagorean identity, 1 minus sine squared of x. And then we have our plus sine x minus 2 sine to the third of x. And we're going to distribute throughout the parentheses. So that first term is going to become just a 2 sine of x. We distribute here, and we will get minus 2 sine to the third of x. And then we'll have our plus sine x minus 2 sine to the third of x. And let me get myself a little more room here. So let's see what we can eliminate here, combine like terms. Let's see, our highest power is sine to the third. We have a minus 2 sine to the third, another minus 2 sine to the third. So that's going to be a minus 4 sine to the third of x. And then we have a 2 sine x plus a 1 sine x. That's plus 3 sine x. And you know, something like this, you'd usually see it written with the positive term first, even though it is of lower power. We could just reverse those and have 3 sine of x minus 4 sine to the third of x. And there we just derived a triple angle formula. So here's a couple practice problems. The first one is very similar to the first example. Set up a triangle in the given quadrant and find sine, cos, and tangent of the angle 2u. And then in the next one, 117, it just says verify the identity. That's just a real quick substitution with our new, see if I still have it, yes, our double angle formulas. You know, this side is real close to something down here. So pause the video, try the problems, come back, check your answers. So let's see here, we're going to set up what quadrant are we in between 3/2 pi and 2 pi. That's fourth quadrant. So here's our angle. This is going to be angle U. And we know sine of U is -3/5. Sine is opposite over hypotenuse. So opposite's going to be 3, hypotenuse is going to be 5. Hypotenuse is never negative, and also this is on, you know, the sort of the y-axis. That is going to be a -3. If we remember our Pythagorean triples, a 3 blank 5 triangle is a 3 4 5. So it looks like we're ready to get started. The sine of 2u is 2 sine u cos u. So we have our 2 sine of u is given in the setup of the problem. That's -3/5. The cos of u we'll get from our triangle. Adjacent over hypotenuse is 4/5. And if we multiply that straight across, we get -24/25. So I'll come down here. The sine of 2u is -24/25. Let's see here. Cos of 2u. And I'm going to use my favorite. That's the same as 2 cos squared of u minus 1. Let's see here, 2. And then we have our cosine of u quantity squared. Cosine is, again, adjacent over hypotenuse, 4/5. That's quantity squared minus 1. So when we crunch that out, we get a positive 7/25. So the cos of 2u is 7/25. And either way we want it, we could set up the tangent formula, or I always prefer the easier route. The tan of 2u is going to equal sine divided by cosine. -24/25, all divided by 7/25. And of course, fraction divided by fraction, invert and multiply. So here the 25s will cancel, and we're left with -24/7. Okay, and number 117, verify the identity. So we want to show that the cos of 4 theta is equal to this over here. Well, what does that look closest to? We have a cos squared and a sine squared. The only thing in our double angle formulas with a cos squared and a sine squared is this one. So it says the cos squared of an angle minus the sine squared of an angle is equal to the cos of just 2 times that angle. So in this, you know, we could sort of think about it like this. What I'm underlining here is our u. U is equal to 2 theta. So if I want to take this term and condense it, I can condense it to cos of 2 times whatever u is. Cos of 2 times whatever we're saying u is up here, and that is 2 alpha. So we're looking at the cosine of 2 times 2 alpha is 4 alpha. Just like what we were trying to show. All right. The assignment for the, oh no, we got a couple more practice problems. What am I thinking? So pause the video again, try this one, you know, set up the triangle in the proper quadrant, and figure out the sine, cos, and tangent of 2u. So here we are between 1/2 pi and pi, so that tells me we're in quadrant 2. Going to set up a little triangle here. And our angle is labeled u. So let's see, cos is 4/5, -4/5, adjacent over hypotenuse. Our x-axis is negative in the second quadrant, so that will be a -4. 5 is the hypotenuse, so we have another 3, 4, 5 triangle. So the sine of 2u equals 2 sine u cos u. Sine u cos u. So our sine of u is opposite over hypotenuse, or 3/5. Our cosine is given as negative 4/5. And if we multiply that straight across, what do we get? Negative 24 25ths. 2 times 3 is 6, times 4 is 24, and it's negative, and 5 times 5 is 25. So negative 24 25ths. Sine of 2u is that. So for cosine, cos of 2u, and I usually use this one, it's my favorite, 2 cos squared of u minus 1. So 2 cos of u was given as negative 4/5, and that quantity is squared minus 1. Now be careful, we're squaring this negative, so that will be positive. That's going to be positive 16 25ths. And when we multiply 2 by that, it's going to be 32 25ths minus 1, which we can rewrite as 25 25ths. 32 minus 25 is 7 25ths. So the cos of 2u is 7 25ths. And tangent, we could use the formula, or we could just say that is sine negative 24 25ths divided by cosine 7 25ths. Invert and multiply 25 sevenths. So these will cancel, and we're going to be left with negative 24 sevenths. And some homework problems to go with what we just covered. Just these 4 problems on page 582 and 583.